What's up? Good morning. Yeah. Today we're gonna be doing triangle congruence. They call me the mathematician. So, I'm the mathematician. If you need a problem, I can't fix it because I can't run. Let me ask you one thing. Yay, math?
Yay, math!
Very good. Very good. That was good. I felt like wind. You know? All right, so the purpose of today's lesson is to prove triangles congruent, right? And that's what we're going to spend the next 20 minutes doing or so. So we want to prove these two triangles congruent. What does congruent mean, real quick? Equal, the same, completely identical, right? All right. One of the ways of proving triangles congruent is by this law called ASA. And we're going to talk about it now. So let's say right now, are these triangles congruent yet?
Yep.
No.
No, they're not. Okay, so let's see. Let's use the red. So now they have one congruent angle. Are these triangles congruent yet?
No.
No, because you could have triangles that have one congruent angle, but their bottoms are all crazy, you know, and they're very different. So these triangles are not congruent yet. What about, now they have one congruent angle and one congruent side. Now are they congruent? Do you think?
Yes. No.
Almost, almost, almost. They have one congruent angle, here it is, in the red, and they have one congruent side, here it is, in the green, and let's do this. Now this is marked with like 2. Okay. Now look closely. They have one congruent angle. They have another congruent angle. And they have a side between them that's congruent, just like it's spelled. Now, can you guess? Are these two triangles congruent now?
Yes.
Yes. Question, please. Okay. I will never mind. So yes, these two triangles are congruent, and they're congruent by the law ASA. What does ASA stand for?
Angle, side.
Angle, side, angle. Very good. So we could say these two triangles are congruent. If they have anything less, then they're not congruent. That's the point. So let's draw two more. So these are congruent by ASA. Next two. All right, you can draw them however you like. Let's do them side by side. Make them look like slightly non-equilateral. And so we ask, are these triangles congruent yet?
No.
No. Question?
Did you say that the ASA is only for 2 triangles?
Well, any triangles can be congruent with ASA, as long as they have the ASA relationship, as in an angle congruent, a side congruent, and another angle congruent. And just like it's spelled, this is something that students miss. Just like it's spelled, the S is between the two angles. So check it out. See how the green one is between the two angles here and here? That's ASA, right? Just like it's spelled. Now we're going to do another one. Okay, so these triangles aren't congruent yet. Let's do this angle congruent to this one. Are they congruent? No. Let's do this side. Again, congruent to this side. Are they congruent yet still?
No.
No. Now we're going to make them congruent by AAS. So notice, the side is not between the angles. So which side should it be? Do you think it should be, or excuse me, which angle should it be? Should it be this angle?
No.
And this? Or the right one, please, in the back?
Bottom right.
Bottom right, that's right. So let's put them in. You guys, good job. I'm glad you're volunteering. Don't be afraid to be wrong. Seriously, it's all good. I'm wrong all the time. It's too bad I'm a teacher. Not good. Yeah. So, but I'm teaching you how to be wrong, so that's part of me. So it works. Spell it! It's fine. Never thought of that before. That's cool. So check it out. 2 angles that are congruent. There they are. 2 angles that are congruent. And a side that's not between them. This, the side that is between them. This side is not between the 2 angles. So are these triangles congruent now?
Yes.
Yes, by AAS. Okay. Any questions? So we're moving on. AAS. Okay, good. So let's try some more. Let's draw 2 triangles like this, kind of back to back. Back to back now. All right. The goal of this lesson and every lesson following it will be to prove two triangles congruent. Two or more, as you said, Cornelius. So, no, that was a joke, I just made that up. So are these triangles congruent? Even though they're back to back, you know, are they congruent to each other yet?
No.
They're not, they're not. All right, so let's see if we can start marking them. Let's use the red. Yeah, question?
If you prove only the top, oh wait, no, if you prove the two bottom sides equal,
These? Yeah.
Wouldn't that prove that it's congruent? Or do you
Not
have to do
enough.
the top too?
Not enough. Yeah, we'll walk through it. Walk through it. Right now, it appears that there's nothing congruent about these two triangles. It appears. But the secret is there is one thing that's congruent about them. So start to think of that in the back of your mind. So let's say if I said this angle was congruent to this angle. So now, do they have an A or an S shared? A. Very good. They have an A shared. Now let's do here. Now these are explicitly 90 degrees each. So do they have another A or S?
A.
Which one is it? A. Okay. So it looks like they have an A, and they have another A. So we need one more, don't we? They come in threes. So we need one more. Does anyone see that there's another one in there hiding? Okay, two people. It's okay if you don't. Keep looking. There's another one in there hiding. It's either another angle or a side. Can you see which one it is? Yes.
So is it the middle one?
This side here?
Yeah.
Yeah, why? Why is it? You're right.
Because they both share it.
They both share it.
Keeps it.
Yeah, yeah. So isn't the goal to prove this triangle congruent to this triangle? And so if we're proving this triangle congruent to this triangle, we say, okay, well, this side, I usually mark it with 3 so it stands out. This side for the left triangle is the same as this side for the right triangle. So these two sides are shared. They're back to back, so they're the same. Any questions about that? This property, does anyone know what it's called? When you look at yourself in the mirror, you see your?
Reflection.
Yeah, so this is called reflexive property. Reflexive property, like if we were to say, if we were to call this side AB, you would say AB is congruent to AB. And this is called the reflexive property. That's something you need to learn. Reflexive property. And the way I remember it is, if you're looking at yourself in the mirror, AB is looking at itself in the mirror. You know, this is like Albert Barenthal, whatever. Albert is looking at himself in the mirror. Why do I think of that name? I have no idea. Albert's looking at himself in the mirror, sees his own reflection, and there it is, reflexive property. It's a good way to remember. Yeah?
Then would AB equal BA? Would that be also reflective?
Sure. Yeah, same thing. Because it's the same line. Okay, so now, are these two triangles congruent?
Yes.
Yeah.
By which law, please?
ASA.
ASA, that's right. And we can tell it's ASA because the side
Is in between the
is
two.
between the two congruent angles. Just like it's spelled, the side is between the two angles there. Questions? Okay. All right, good. We're moving along. Let's do another one of these, back-to-back ones.